Welcome to the DIY Honda Garage channel. The DTC P0502 indicates a problem with the CVT speed sensor circuit, specifically relating to an open or short in the electrical circuit. This DTC is critical as it affects the vehicle's transmission performance. The CVT, or continuously variable transmission, uses the CVT speed sensor to monitor the speed of the transmission and relay this information to the Transmission Control Module, TCM. If there is a fault, it can prevent the transmission from operating properly. Troubleshooting should begin with verifying the DTC and checking the relevant connections in the circuit. It's essential to understand that mechanical issues within the transmission can't cause this specific DTC, so diagnostics must focus on the electrical components and wiring. The CVT speed sensor is integral to the transmission system. This sensor monitors the speed of the output shaft in the CVT and sends crucial information to the TCM. The TCM uses this data to adjust shift patterns and optimize engine performance. Typically, the CVT speed sensor is located near the transmission housing, making it accessible for inspection. A malfunction in this sensor or its circuit could lead to erratic shifting or poor acceleration, and this is precisely what DTC P0502 aims to address. Reviewing the Diagnostic Trouble Code, DTC, provides insight into the electrical issues affecting the sensor circuit, focusing on connectivity and voltage supply. Several issues could lead to DTC P0502 being triggered. First, an open or short circuit in the wiring can interrupt the signal from the CVT speed sensor to the TCM. These electrical failures can stem from frayed wires, corrosion, or loose connections. Poor connections between components, such as terminals, can also impact electrical flow, leading to this DTC. Additionally, a malfunctioning CVT speed sensor may not transmit accurate data, triggering this trouble code. Understanding these potential causes aids technicians in systematically diagnosing the fault and applying the necessary repairs. Symptoms associated with DTC P0502 can manifest as significant transmission issues. Drivers may experience erratic shifting, where the vehicle fails to engage or disengage correctly between gears, leading to a rough driving experience. This could feel like hesitation or slipping during acceleration. Additionally, erratic acceleration may occur, where the engine output does not match driver input, making the vehicle unpredictable. Often, the check engine light will illuminate on the dashboard, prompting the need for diagnostics. Recognizing these symptoms allows for quicker identification of the DTC and reduces further risk of damage to the transmission. In the first step of troubleshooting DTC P0502, the technician should first turn the vehicle ignition to the on position, enabling electrical systems without starting the engine. Following this, it's essential to clear the DTC using an HDS or Honda Diagnostic system, which can provide real-time data about the vehicle's health. Once cleared, the vehicle should be safely lifted on a ramp or lift, ensuring that all four wheels can rotate freely. This setup is vital for further testing, where wheel speed and engine performance need to be evaluated. After this, the next steps involve performing a series of tests to gather data about the CVT speed sensor's functionality and the integrity of its electrical circuit. Step 2 focuses on identifying the possible failure area, starting with the VCC3 line. The technician starts by turning the vehicle to the off or lock position to ensure safety while working on the electrical components. The next crucial action is to disconnect the CVT speed sensor's 3P connector, isolating it from the circuit for accurate testing. Subsequently, the ignition is turned back to the on position while the connector remains disconnected. In this state, The technician measures the voltage between two specified test points on the connector. Confirming the presence of approximately 5 volts is crucial, as it indicates a functioning power supply to the sensor. If voltage is detected, it directs troubleshooting toward the next steps. In Step 3, the focus is on evaluating the condition of the VCC3 wire. After ensuring the vehicle is in the off position for safety, the technician disconnects the TCM's 50P connector, which links the TCM to the CVT speed sensor circuit. Continuity checks are imperative at this stage. The technician will take measurements between two designated test points. Performing continuity tests allows for the detection of any open circuits within the VCC3 wire, which would indicate connectivity issues. If continuity is confirmed, the wiring is likely intact, guiding the technician to consult authorized service information for further diagnostic options, or to test with a known good TCM. Conversely, if continuity is absent, the technician would need to repair any identified breaks in the wiring. Step 4 centers on checking the SG3 line for integrity. The technician measures the voltage between two specific test points while the CVT speed sensor 3P connector remains disconnected. Again, vehicle must be in the on position for the test. Finding approximately 5 volts confirms that the SG3 wire is functional and relaying correct signals. If this voltage is present, the troubleshooting can progress to the next step. However, if the voltage is not detected, this indicates an open circuit in the SG3 line, which must be repaired. It's critical for the integrity of the sensor circuit to ensure that all wires are intact and free from breaks or cuts. Moving to Step 5, the technician will be looking for potential shorts in the VEL PWM wire. This action begins with the vehicle in the off position, and the technician disconnects the TCM's 50P connector, isolating it from the circuit for accurate measurement. The aim is to test for continuity between specified test points. Conducting this test determines whether the VEL PWM wire has become shorted to ground, a failure that can significantly impact sensor operation. If continuity is detected, it indicates a short circuit exists, necessitating repairs. If not, it suggests that the wire is intact, allowing the technician to move forward in diagnosis. In the final step of the troubleshooting process, the technician verifies the state of the VEL PWM wire by conducting a continuity test. The vehicle should be off, and both the CVT speed sensor and TCM connectors need to be disconnected. This precaution ensures accurate measurements without interference. Continuity is checked between the relevant test points to confirm that the wire is intact. A successful test would indicate that the wire is functioning properly, leading to the recommendation to replace the CVT speed sensor if the issue persists. However, if continuity is lacking, the technician must address any breaks in the VEL PWM wire, ensuring the integrity of the electrical circuit is fully restored. To conclude the diagnostic process for DTC P0502, it is essential to conduct a thorough final repair verification. This begins by checking the vehicle's onboard diagnostics for any stored DTCs after repairs are made, ensuring that the P0502 code does not reappear. Subsequently, a test drive is necessary to validate the effectiveness of the repairs, allowing the technician to observe the vehicle's performance under real-world conditions. During the drive, the technician should look for any signs of abnormal shifting or other symptoms previously associated with the DTC. A successful test drive confirming smooth operation, free from DTCs, signifies that the repair was effective and the vehicle is back to optimal condition. Preventive maintenance plays a crucial role in avoiding future occurrences of DTC P502. Regular inspections of the CVT system, particularly the sensor and wiring connections, can help identify potential problems before they escalate. Technicians should routinely check for corrosion, wear, or loose connections along the wiring harness, especially in locations exposed to heat or moisture. Ensuring the integrity of electrical components and staying ahead of issues with the CVT speed sensor can dramatically improve the system's reliability. Furthermore, educating vehicle owners about monitoring any unusual driving behavior can lead to early detection of sensor or circuit issues, prompting timely diagnostics. In summary, DTC P0502 signals an electrical circuit issue related to the CVT speed sensor, emphasizing the importance of diligent troubleshooting. Recognizing that this DTC is not caused by mechanical failures in the transmission guides the technician toward a systematic approach, prioritizing electrical connections and sensor integrity. Each troubleshooting step is essential for isolating the fault. From verifying DTCs to checking continuity along critical wiring lines, ensuring thoroughness in the process amplifies the chances of restoring proper function to the transmission. Awareness of preventive maintenance practices further aids in minimizing the risk of recurrence of this DTC, contributing positively to the longevity and reliability of the Honda Civics transmission system. Please like and subscribe to the channel. See you next time.